Hello, today's topic in 2-minute fire physics is the laws of thermodynamics. The zeroth law of thermodynamics states that when two bodies are in thermal equilibrium with a third body, they are in thermal equilibrium with each other. When we say that systems are in thermal equilibrium, it means that they have the same temperature. In simple terms, the first law of thermodynamics states that energy is conserved. It cannot be created nor destroyed. Mathematically, the first law of thermodynamics is written as the change in the kinetic, potential, and internal energy of a system during a process will be equal to the net amount of heat transfer occurring during this process minus the net amount of work performed during this process. The amount of heat Q that is transferred to or from a system can be calculated by considering the integral of heat transfer rate over a period of time delta t. The amount of work W can be calculated by considering the integral of the dot product of a force F times the displacement ds, or by the product of pressure P times the change in volume dV. If there's no significant change in kinetic and potential energy, then the first law of thermodynamics reduces to the change in internal energy is equal to the net amount of heat transfer occurring during this process minus the net amount of work performed during this process. In the special case where also no work and no heat transfer energy occur, then the first law of thermodynamics states that there will be no change in the internal energy of a system. The second law of thermodynamics states that the total entropy of a closed system either increases or remains constant during a process. It never decreases. When ice melts, it becomes more disordered and less structured. Its entropy increases because of heat transfer into it. In general, entropy S can be seen as a measure of a system's disorder and of the inability of energy to do work, or a measure of the energy spread. The third law of thermodynamics states that a system's entropy will be zero at absolute zero temperature. Absolute zero is defined as 0 degrees Kelvin or minus 273.15 degrees Celsius. Increasing the temperature of a system will result in an increase in its entropy as well. The statement of the third law of thermodynamics is true for crystalline solids. However, for non-crystalline solids like glasses, the entropy at absolute zero will be typically close to zero. This concludes today's topic. Thank you for watching the video.